The fourth topic of this lecture is control chart for attribute. Attributes often classified as defective or non-defective. Variable chart that we looked at was just looking at the trend and how they are performing for means. However, control chart like the number of defectives that you have found after inspecting a product, right? Or number of recalls that you have received from your customers per day. So it follows a different sampling method, and also distribution. At the time, we have to use different types of chart, and they are P chart and C chart. P chart measure the percent defective in a sample, and the C chart are counting the number of defects in a sample. So let's first look at P chart. Attributes that are good or bad typically follow the binomial distribution. If the sample size is large enough, a normal distribution can be used to calculate the control limits. And the formula are UCLP equals P bar plus Z times sigma of P. And the lower control limit is just subtracting Z times sigma P. P bar is fraction defective in the sample, and Z is, as you learned, 2 or 3. When you have a 95% of confidence level, you use 2. If you have 99% of confidence level, then you are going to use 3 for the Z value. Sigma P is standard deviation of the sampling distribution, and sigma hat P, you have to estimate that, is square root of P bar times 1 minus P bar over N. That's the formula that you want to use. Control chart for attributes. So here are the control chart that you want to use, and we want to calculate how we can find the upper control limit and lower control limit for this case. So as you can see, you have a sample number 1 to 10, 11 to 20, and number of errors are given here, and you want to calculate fraction defective. So this is if you look at uh, the, the, the textbook, the sample size is 100. So they are producing 100, and and out of 100, they found 6 defects for sample number 1, for sample 2, 5, sample 3, 0, and so forth. So 6 over 100 gives you 0.06 as a fraction defective. So 6% of the sample is defective. That's what it says. And 5 of them, so 0.05, and so forth. And it goes on, and the total number of defects was 80. So given this information, let's calculate the control chart for attribute. P bar equals total number of errors divided by total number of records examined equals total number of error was 80, as we saw here, and total number of records is that the sample was 100, and you see 20 times we have sampled. So 100 times 20 gives you 2,000. And if you divide it by 2,000, then it gives you 0.04 as P bar. And average fraction of defect rate, that's 4%, which is pretty high. Now, sigma P equals P bar times 1 minus P bar, right? So 0.04 times 1 minus 0.04 divided by N. N is 100 right here, right? That's a sample size, and equals 0.02. So you get 2 as your sigma P. Then now you can calculate your upper control limit and lower control limit. So UCL P equals P bar plus Z times sigma P equals 0.04 plus 3 times 0.02, which is 0.1. LCLP is just subtracting Z times sigma P from P bar. So you do that, and it's negative actually if you do that, because 0.04 0.02 times 3 is 0.06, so negative 0.02. However, as I said, there's no negative percentage, so it should be the lowest one, which is 0. So 0.10 is lower upper control limit, 0 is lower control limit. Then now you can draw your control chart. So we have upper control limit 0.10, lower control limit 0. Center line is P bar, which is 0.04, and you just plot these these points out, and you see it's within the limits, first of all, but this one at 17, sample 17 is out of the boundary, and we need to look at why this is the case, right? And also we want to see whether the 5 rules that we learned is applying to this case, right? So um, you know we need to closely examine this one. This part I'm not really confident because it's just staying here all the time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So um, 10 out of 8 is staying on this side. So I feel like we need to look at this part and what happened that needs to be inspected. So if you use Excel, I'm going to show you shortly. So this is a sample and the table that I drew, and I put all this information and formula here, and then after calculation I visualized it, and I found the CP is 0.84, and CPK is 0.58 for this case. So let me show you shortly how to do Excel for this chart.